Everyone. So today we will cover chapter 2, introducing list of Python materials. So in this we will see like how Python lists replace scattered variables with a single ordered indexed collection. So if you see over here on the left, we have these scattered variables in the form of sticky notes, and this we have replaced by a single collection on the right, which we call as a list. Okay, and that list we have given a name bicycle. So today we will understand like what lists are, okay, and the various operations which we perform on the list, and the various things we can do with list and why they are necessary. So let's proceed. So if you see over here, the first thing they say like why list matters, the so what, okay, the problem of scattered data. So what they are trying to say, like imagine trying to manage the inventory of a bike shop, okay. Tracking every individual item separately means juggling individual variables like bike 1 is equal to track, bike 2 canodale, bike 3 is equal to redline. What does this mean? Like suppose you have you have a bike shop, okay, and you are managing a large customer base, and if you like just put your like customer what bicycle they have, okay, in the form of sticky note, then it will be a huge pile of data, okay, and you won't be able to like properly find a customer bicycle, and it will create lot of chaos, okay. So uh, what is the solution? The solution will be an ordered collection, okay. So that ordered collection in Python we call it as a list, okay. So if you see over here, where we had we arranged everything, okay, in the form of proper folders, okay, and we put them in a proper cabinet, okay. So we have arranged all of this in a certain order, so that's it's easier to find, okay. So this collection we call it as a list, okay. So now let's move on to the next slide, okay. So now we have, so in order to understand it, let's imagine a real world analogy, okay. So what we will understand list through the hallway of lockers, okay. So what is mentioned, like to understand how Python stores grouped data, imagine a long hallway. So let's imagine this is a long hallway of numbered school lockers, okay. So here if you see we have these lockers, okay. Before list, you have to hold your belongings in separate hands, dropping things as you walked. So what does it mean? Before lockers were there, what used to be that, okay, you have to like hold all your things and belongings in your hands, okay, and as you walk through the corridor, okay, you drop your things, okay. You used to drop your things, okay. So it was like hard to manage your belongings, okay. So then we came up this with this locker hallway of locker solution, okay. So what problem it solves, okay. So then you after this hallway of like lockers were created, okay, then you started putting all your items into one single continuous row of lockers. You started putting all your items into these lockers, okay, and you gave one entire row a name like a bicycle. So you gave all of this locker name as bicycles, okay. So whenever you need anything, what you will do, you will simply go to this bicycles lockers, okay, and you will just see the cabinet, okay, in which your item is stored, okay, and you will just directly open your cabinet, okay. So it becomes very easy to find your item and very easy to manage, okay. So now let's move on to the next slide. So next, now we will officially start with the definition of the list. So what is a list? A list is an ordered collection of items grouped under one single variable name. So here few things we have to keep in mind. First, it is an ordered collection. Okay, it is an ordered collection, means in list the items are arranged in a certain order. Okay, and all of this, okay, are assigned under a single variable name. Okay, so what does that mean in plain English? So you can put like anything into a list: letters of the alphabet, digits from 0 to 9, the numbers of your family members or vehicle brands also, because lists usually contain more than one item. Okay, so it's best practice to make the variable name aim which you are assigning to a list as a plural. So instead of like saying letter, you call it letters. Instead of saying digit, you call it digits. Okay, so always assign plural. So how it like uh, how you can imagine this? Okay, like this is your list, okay, in which each cabinet, okay, is a position, okay, in which you have stored your particular item. Like in position 1, okay, you have stored like your Trek brand bicycle. In position 2, you stored your Cannondale type bicycle. In position 3, you stored your Redline in type bicycle. Okay, and all of this, okay, all this cabinet you gave it a plural name called bicycles. Okay, so that it becomes easy for you to later find, okay, where I have like stored my red line bicycle. Okay, you can just simply come to this bicycles list, okay, and locate this red line bicycle. So now let's move on to the next slide. So next we will like see the syntax of the list. Okay, so if you see over here, there are two parts in the list syntax. First are the square brackets. These construct the locker rules. Rule whenever you see opening and closing square bracket in Python, okay, think it of as a list. Okay, so what does this mean? Okay, your list always will start with the opening square bracket and will end with the closing square bracket. Okay, so now the second piece is the commas. So you separate each item of the list with a comma. Okay, so if you see over here, track is separated by a comma from Cannondale. Cannondale is separated by a comma from Redline, and so on. Okay, and you give all of this a variable name, okay, which we are calling over here bicycles. Okay, so now let's move on to the next slide. So next is like the index. So what is index? So suppose now you have created this list, okay, and you want to like locate a particular item. Okay, so in order to locate that particular item, you know you have to know its position. So that positioning is basically the index. So here they have mentioned like the what is index? It's the official position number of the item within a list. Okay, so so what they are saying, like once your data is neatly packed into a list, you need a way to tell Python exactly which item you want to interact with. Okay, so if you want to like understand the index using real world example, so again consider our this locker room analogy. Okay, and in this they have mentioned like your the locker number, okay, is essentially the index. So why is it that? Because suppose you want to find the red line type bicycle. Okay, so you know like, okay, my track bicycle, it is at first cabinet, second Cannondale is at second cabinet, and red line it is stored at third cabinet. So the position is like the third cabinet. Okay, so that positioning, okay, is essentially the index. Okay, and one thing you have to keep in mind, okay, like we humans generally we start counting from one. Okay, like this is first cabinet, this is second cabinet, this is third cabinet. But in Python, the positioning number starts from 0. So track is actually stored at 0 position. Canodale is stored at 1 position. Red line is stored at third position. So if I ask you the index, which index number which will be used to find red line, so it will be 2, because it is like sec, it is stored at the second position. So if you want to see it, so it will be like so let me show you like how it looks. Okay, so over here if you see, this will be your zeroth position. Okay, which will point to this track. Okay, this will be your first position, which will point to Canodale. Okay, and this will be your second position, which will point to red line. So this second position is actually the index to find red line bicycle within the bicycles list. Okay, so now let's go to that slide. Okay, so that's what list is about. Okay, and if I have to just show you through a simple example, so let's us consider like we have a simple list. Okay, I will call it A. Okay, and in this I will like just have some like alpha, we can say like some names we can have. Okay, so first name I will put like Eric. Okay, second name I will put as John. Third, I will put as Mira. Okay, right? So Eric has an index of 0, John has index of 1, and Mira has index of 2. Okay, so in order to like locate Mira, okay, what you will do, you will simply type A of 2. Okay, so that will actually point to this second position where Mira is stored. Okay, so I hope now it's clear. So now let's move on to the next slide. So here they are mentioning the same thing, the zero index mastery, the gotcha of programming. So they are mentioning like Python lockers do not start at locker 1. Okay, they start at locker 0. So the one thing you have to always keep in mind that Python index numbering always starts at 0. Okay, and they have also given the reason also for that. Okay, so what is the reason for that? Okay, the reason is it's based on how computer memory works. In computer science, an index is actually an offset, a measure of how a measure of distance from the starting line. Okay, so it's actually it is a measure like how far you are from the starting line. So if you see track, okay, and this is your starting line, track is actually 0 steps away from the start, so that's why its index is 0. Canodale is actually one step. This we are calling it as one step. Okay, so he is Canodale is actually one step away from this starting point, so that's why its index is 1. Okay, and red line is 2 steps away. Okay, that's why its index is 2. Okay, so now I will just like mark it for you. Okay, so track is actually just 0 steps away. Okay, so let me change this to pen. Okay, and I will mark it for you. So track is 0 steps away from the starting. Okay, so this is 0 steps away. Okay, Canodale is 1 step away. Okay, and this red line here you have 1 step, and here you have again 1 step. So in total you are having 2 steps away. So that's why its index is 2. Okay, so that you have to keep in mind. Okay, so now let's move on to the next slide. So few terms we have to keep in mind. Okay, So first is the list. Okay, so what is the list? It is an ordered collection of items grouped under one name. Okay, so example is like you have this bicycles list. Okay, which here you see it is starting with the square bracket, ending with the square bracket, and in between you can have any number of items, or you can have an empty list also. Okay, what are the next thing is, what are these square brackets? Thus these symbols are used to construct the list. So here if you see, we have this starting bracket, we have this closing bracket, and within that we have two items. Okay, so this is the purpose of square brackets. What is comma? So comma separates the items within a list. So if you see over here, this comma, okay, over here is separating A and B within a list. Okay, so what is an index? So index is the official position number of an item in the list. So if you see over here, okay, so suppose let's consider this example, A and B. Okay, so here the index of A is 0 and index of B is 1. Okay, because A is 0 steps away from this starting position. Okay, and B is one step away from this starting position, so that's why its index is 1. Okay, so and if you want to access any item, you just mention the name of the list. Okay, this is the name of the list and its index position. Okay, so that you have to mention. Okay, so if you type any list after that 0, so it will always access the first item within that list. Okay, so after that, the last is, what is a method? So method is a built-in action Python can apply to a piece of data. So think of it as like basically a function, okay, which you apply to a list. Okay, so which can manipulate the list. Okay, so now let's move on to the next slide. So after this, okay, now we come to accessing items of the list by index, opening the locker. So let's understand it through an analogy. So what they are mentioning, to access an item, write the name of the list followed by the index of the item inside the square brackets. So if you see over here, here they have mentioned like print bicycle 0 dot title. Okay, so now they have mentioned the trace also, like how it works. So first Python locates the variable which is bicycles. Okay, so it sees what bicycles is. So as you have seen, like in the few last slides, okay, bicycles is a list. Okay, so it knows it's a list. After that, we are placing this 0 within the square bracket. So what does it mean? We are accessing the first item. The first item, if you remember from the last slide, okay, it was track. Okay, after once we have come up to here, okay, we have track over here. Then we apply a method dot title. Okay, so what title does, it will capitalize the first letter of the word. So this small t will change to capital T. Okay, so this is the purpose of this method dot title. Okay, after this, okay, once we are done with all this piece, okay, over here, okay, all this gets wrapped into one print statement which will actually print this track on the console. Okay, so that's how, like, the main point is, if you want to access any item of the list, first mention the list name. Okay, list name. Okay, for and in the square bracket mention which index you want to access. Like suppose you want to access the second index, okay, mention second. And always remember, Python list index starts at 0. Okay, so that you have to always keep in mind. Okay, now let's move on to the next slide. Okay, so here they have mentioned like building a sentence from list data. Okay, so what does it mean? Okay, you can pull, and so we will again understand it through a real world example. So you can pull an individual value from a list and use it just like any other variable. A common use case is using concatenation, this plus symbol, to inject list data into a readable sentence. Okay, so overall, like, I know, like, this sounds too confusing. Okay, but overall, what does it mean? Okay, like, you can have a string. If you see over here, we have this string, my first bicycle. Okay, and this we are just concatenating. If you remember from the previous video, we use this concatenation operator, plus operator. Okay, and what we are concatenating, we are concatenating the first item of this bicycles list. Okay, and we are like converting it to a title case. Okay, so if you remember from last slide, okay, the output of this was this track variable. Okay, so this we are concatenating with this, my first bicycle was, okay, was a track, and then again we are using the concatenation operator, and we are concatenating this periods symbol. Okay, so overall what it becomes, my first bicycle was a track and then a period. So what you will see in console, my first bicycle was a track and followed by a period. Okay, so this is how you like build a sentence from list data. Okay, so if we come to the execution trace, okay, for this piece specifically. Okay, so what does it mean? Python grabs track from locker 0, means position 0, index 0, and capitalizes it to this capital T track, because we have applied this dot title method. Okay, so after this it glues the starting strings and dynamic list data together, so then it concatenates everything and give you this final string over here, right? So that is what it is essentially. Okay, so now let's move on to the next slide. So the negative index trick. Okay, accessing the end of the list. Okay, so lot of times, okay, you will come up across a scenario where you will want to access the last item of the list, but you won't know its exact position from the starting, like what will be its exact position from the starting. Okay, so in that scenario, okay, there is a special trick, okay, which is known as negative indexing. Okay, so if you see over here, they have like given like print bicycles -1. So your positive indexing, in order to understand it, what we have to do, okay, we have to like see how positive indexing work and how negative indexing works. Okay, so if you see over here, your positive indexing starts from 0 and it goes from left to right. Okay, it goes from this left to right. Okay, and your negative indexing, okay, it starts from the very right. Okay, and it starts with -1, and then it goes from right to left. Okay, so if you see, it goes from here to here. Okay, so what does that mean? Okay, like, in order to access the last item of the list, okay, you can simply use these bicycles is this name of the list. Okay, and -1. Okay, so in -1, what we are having, we are having this specialized item. Okay, so this will get printed on the screen. Okay, so now the same thing they have mentioned, like how it works. So by asking for -1 index, Python counts backward from the end of the list. Okay, and always return the last item. This truck extends backward. Example, -2 returns the second item from the end. So if you type -2, it will return the second last item from the right. Okay, so which will be this red line, because its index is -2. Okay, so I hope now you have understand the use of negative indexing. Okay, so basically, in simple terms, if I have to explain like when to use it, when you don't know the like exact position of your like end strings, and you want to like extract some end items from your list. Okay, so in that case you can use negative indexing. That will be much better. Now let's move on to the next slide. Okay, so here we have clean output versus raw data verification. Okay, so if you just type, okay, print of bicycles, okay, so it will just print this list. Okay, but a user might be interested in just a particular item. Okay, so you have to type like bicycles, you have to access his index, okay, so that you can get that particular item, and then you apply your method over it to convert it to your required format. So what they have mentioned over here, why access specific indexes. So if you simply ask Python to print the entire list variable, it returns its raw internal representation, including all the brackets, quotes, everything. Okay, including all the brackets, comma, quotes, everything. By accessing specific indexes, we avoid showing users raw syntax. We deliver clean, professional, and formatted user data. So once you have started using index, then you can just show him the item within that collection. Okay, one particular item within that collection. So that's what they have mentioned over here. So now let's move on to the next slide. So here now they have mentioned lists are dynamic in nature. So lists are dynamic in nature. So what does this mean? The living clipboard analogy. So again, we will understand it through an analogy. So far, our list has been static. So far, in the previous, you have seen like our list was not getting updated, no new items were getting added or deleted. Okay, so it was like kind of a static. But from this moment onwards, okay, the list, okay, we will see like how they are dynamic in nature. Okay, so what they are mentioned, but in Python lists are dynamic. Unlike a physical cardboard box that can only hold a set number of items, a Python list expands and contract automatically. What does this mean? Like Python list from a list in Python. Okay, suppose you have a list in Python, you can add new items to it, you can delete items from it, you can even change the values of items within a list. Okay, so that's why since you can do add, delete, and modify, okay, the lists are dynamic in nature. So how to like think it. So think of list not as a locked boss, but as a restaurant host managing a waiting list on a clipboard. So you can think list as he is noting down the name of persons who have booked, who have like arrived, okay, on like a noting pad. Okay, so in this, if you see, he can add new names, which will be like adding new items to the list. Okay, na- uh, adding new items to the list. Okay, he can also change the name of the person, okay, which will be, we will call modifying. Okay, then he can uh, push VIP members to the top, okay, which will be like inserting item at a certain index of the list. Okay, and he can even like delete or remove some items, okay, which we will call like popping, okay, and deleting items of the list. So now we will see all these operations: modifying, appending, inserting, deleting, and popping. Okay, in the next slides. Okay, so let's see. So first we will see modifying. Okay, so we let's see this analogy. The host crosses out Smith and writes Smithe in the same spot on the list. So if you see over here, okay, let me just remove this one. He has crossed out Smith, okay, and in that same position he wrote down Smithe. Okay, so that means what he did, he actually changed the value of an existing item. Okay, so how, now we have understood the analogy, but now let's see how we do it in Python. Okay, so modifying an item by index, crossing out and replacing. The syntax to modify an element is identical to accessing it, but we assign it a brand new value using the equal to sign. So what does this mean? Suppose you have a motorcycles list. Okay, and the list contains items like Honda, Yamaha and Suzuki. Okay, and in order to like learn, and let's suppose you want to like change this Honda item to Ducati item. Okay, you want to like simply change the value of this. So what you will do, you will type the name of your list, which is motorcycles. You will in within square brackets, okay, you will type the index of that item which you want to modify. So here I want to modify Honda. So if you see over here, Honda is at 0 position. Okay, Yamaha is at 1 position, Suzuki is at 2 position. I want to modify Honda, that's why I will put 0 over here. Okay, so that's why 0 has come over here. And then you will put one equal to symbol, and after that you will put the value of the new item. Okay, so which we are saying Ducati. Okay, so now if you see over here what has happened, once we have like written this and once we will run this one, what will happen? Earlier in the list we were having Honda, Yamaha and Suzuki, and now Honda is replaced with Ducati, but Yamaha and Suzuki stayed the same. Okay, so how Python does it? So Python goes to the locker 0, completely deletes Honda and replaces it with the Ducati. The rest of the list remains untouched. Okay, so now let's move on to the next slide. So here they are mentioning appending to the list. Okay, so what does append means? It means adding items to the end of the list. Okay, so suppose you were having already Honda, Yamaha and Suzuki and you want to add Ducati, so you will use append method for that. Okay, and append always adds item to the end of the list, it never like adds it in between. Okay, it always will uh, add item to the end of the list. So here if you see what we were having earlier, we were having list as list containing Honda, Yamaha, Suzuki, but after like calling motorcycles, which is our which is our list, and you access the method using dot operator, dot append method, and within append you what you want to like append, that name you have to provide, that value you have to provide. So I want to append Ducati. So once you have run this piece of code, okay, what will happen? Okay, it will like say Honda, Yamaha, Suzuki and Ducati will be added to the end of this list. Okay, and suppose now after that you again like added Yamaha 1. Okay, like suppose you added Yamaha 1, okay, in the append. So after Ducati you will see Yamaha 1 is added. Okay, Yamaha 1 will get added. Okay, so here they have mentioned Python automatically expands the size of the list by one slot and places the new item at the end, Okay, next we come to the scenario. Okay, like see, through append you can only add items to the end of the list, but what if you want to insert an item at a certain position? Okay, okay, so for that we have this insert method. Okay, so what we have like squeezing an item in, The dot insert index comma value method opens up a new space at the exact index you specify and pushes everything else to the right. So what does it mean? Okay, like suppose in your restaurant analogy, okay, you already were having some members, but now a VIP member came. Okay, so what you will do, you will keep the VIP member at the top and push all the other members down. Okay, so that's what they are doing. Okay, so what they are saying, like suppose you were earlier having this Honda, Yamaha, and Suzuki. Okay, so over here they have mentioned like Honda, Yamaha, and Suzuki, and you simply wrote like motorcycles, which is your list, dot insert, which is the method, and it contains two parameters. Index is where you want to insert this value, so we put 0 like at the very starting, and what will be the name of the value of the uh, item which you want to provide, that you have to provide. So here in this case it's Ducati. So at index 0 Ducati will get inserted. Okay, so which is, as you see over here, it got inserted, and everything else, this Honda, Yamaha, Suzuki, will shift to right by one index. So if you see, earlier Honda was having index of 0, Yamaha was having 1, Suzuki was having 2. But now Honda is shifted by 1, Yamaha is shifted by 1, and Suzuki is shifted by 1. Okay. So now if you see here, it mentioned like at index 0, now Ducati is stored. Okay. Next comes deleting by position. So erasing an item forever. Okay, let's suppose like a person didn't came up, okay, at your restaurant, but he has booked. So what you will do, once he didn't arrived on time, okay, and after waiting for few minutes, you will just strike his name. Okay, so you will remove his name. So in Python, okay, we do it by like two methods. Okay, so first we will see this del method. Okay, so if you type del motorcycles of 0, so what it will do, it will go to the motorcycle list. Okay, if you see that that is having Honda, Yamaha, and Suzuki, and after this, okay, you just access your item. Okay, like suppose I want to delete the first item of this motorcycles list. Okay, so I will just type motorcycles, then access its first item by index, which is 0, so that I have accessed. Okay, so Honda is now like I have accessed, and it's saying like delete Honda, so it will delete the Honda, and it will shift all the rest positions to the left by one index position. Okay, so that's why Yamaha, which was earlier at one position, now is coming at 0 position, and Suzuki, which was at second position, is now coming as at first position. Okay, so that's what they have mentioned, like Python deleted Honda completely, you can no longer access its value. Okay, so it has permanently deleted it, you can no longer access it. The second is popping an item, removing and using an item. Okay, the next table is ready. The host calls the name, seeds them at the table using data, and then removes them from the waiting list. So in order to like understand it, let's take a real world analogy. What does it mean? Like suppose you have these names, okay, for the persons like who have booked okay, booked your restaurant. So what will happen once a person has arrived, you will like simply strike out their name. Okay, so that you can be sure, okay, they are now seated at the table. Okay, so that's what pop method does. Okay, the pop method, if you see over here, the pop method removes the last item in a list, but it holds on to it so you can use it one last time. Note dot pop 0 pops from the beginning. Okay, so what does this mean? You have this method called pop. Okay, this, if you don't provide any argument over here, okay, will always remove the last item from the list. Okay, but if you provide a certain index like 3 or like 4, okay, so it will remove that particular index item. Okay, and one thing you have to keep in mind, like this, you might be thinking this we can do with del also, but why we will need pop? So the answer is like del deletes it and does not like store any value. Okay, whereas pop, what it does, it removes last item or removes the specific item which like user has mentioned from the list. Okay, and store it in a variable. So if you see over here, they are mentioning like before Honda was there, Yamaha was there, Suzuki was there, and now they have like called this list dot pop. So what happened? This Suzuki got removed from the list. If you see, Suzuki is not there, but this Suzuki, okay, it got like stored in a variable, okay, which you can reuse later. Okay, so that's what we do. Okay, so in simple terms, if I have to say, if you type like b is equal to a dot pop of 0, so what it will do, it will like remove the first item from the list and store it in this b variable. Okay, so that's what pop is doing. So now let's move on to the next slide. Okay, which is like remove method. So removing items by value. So see, in pop you were removing it based on the index position, but it will be very likely the case that you might not always know the index of the item you want to remove. So you only know its value. Okay, so what will happen? Okay, at that time you can't use pop method, you have to use this remove method. So what will happen over here? So you will simply type your list. Okay, list dot this remove method, and you type the value, like suppose it is like Honda. So you have to simply type Honda over here. Okay, so it will be list dot Honda. Okay, so how remove method works? So how remove method works? Okay, so in the ideal case, when you know what you want to delete, the user JDO, but have no idea which locker number they occupy. Okay, as I told you, like you know the value of the item but you don't know its position, so in that scenario you will use remove method. Okay, so uh, what it does, the remove method, okay, it scans your list. Okay, it will scan your list, and whatever like you have mentioned in this parenthesis, okay, it will find that value and it will remove that value. Okay, but here is one catch. If you have like suppose you have typed Honda over here, and in the list, okay, you have multiple Hondas. Okay, you have multiple Hondas, it will always just remove the very first value it will find for that. So suppose in the list, okay, if I tell you in a simple manner, okay, like I am having this list 1 2 1 4. Okay, and I type a dot remove A dot remove 1. Okay, so what will happen? It will just remove this first one. It will like leave this second one over here. So your list will become 2 comma 1 comma 4. Okay, it will become that. Okay, so now let's move on to the next slide. Okay, okay, so now let us do one thing. Okay, let's move on to the next slide. Okay, and here you can see what we are doing. Okay, we are building a list from scratch. So here if you see, we have defined an empty list, motorcycles. Okay, so think it is as an empty shelf. Okay, now what we did, we are doing motorcycles dot append Honda, so it will add this Honda to this empty list. Okay, then you what you did, you again typed motorcycles dot append Honda, so append Yamaha. So you were already having Honda in the list. Okay, so append will always add to the end of the list. So what will happen, this Yamaha will get added after Honda to the right. Okay, so that's what they are mentioning, like dot append always attaches exclusively to the far right, like it always attaches items to the end of the list. Okay, now here again we are like tracing it. Okay, so here now we have in list motorcycles, we have two values, Honda and Yamaha. And if we now do motorcycles dot insert 0 comma Ducati, what will happen? So if you know, like Honda is having like index of 0, Yamaha is having index of 1. Okay, so what we are doing, we are telling like insert Ducati. Okay, this new item Ducati at position 0. So what will happen, Ducati will get inserted at position 0 and this Honda and Yamaha will get shift by 1 index. So Honda index will become 1, Yamaha index will become 2. Okay, so this is what will happen. Okay, after this, okay, we like told like Ducati is too expensive. We created a variable too expensive is equal to Ducati, and we told like motorcycles dot remove two expenses. So it what it will do, okay, it will find where in the list Ducati is there. So it will see, okay, Ducati is over here, and it will remove that. So it will remove Ducati. Okay, and these all this Honda and Yamaha will shift to the left by one index. So here their index will become 0 and 1. Okay, so that's what they are mentioning. And suppose like you were having like two Ducatis over here. Okay, like here also after Yamaha, suppose you were having one Ducati. Okay, so when you called like remove, okay, it will like only remove the first occurrence. So it will only have removed this Ducati. Okay, so in the end you will be left with Honda, comma Yamaha, comma Ducati at position number 2. Okay, so that's what you have to keep in mind, that remove always removes only the first occurrence. Okay, so that you have to keep in mind. So after that we come down to this extracting and utilizing data. So suppose you have now this list motorcycles which is having two items, one is Honda, one is having Yamaha. So sometimes you must pull the last item of the list but hold on to it to process it one time, like calling a waiting guest to their table before crossing off their name. So what does it mean? Like if suppose like you have like some items, okay, on your list, okay, but and your guests are waiting for it. Okay, So you want your guest to try out that items, okay? So you just like hold on to that item till your guest arrives, and once your guest has arrived, okay, you just tell them, okay, like this item is like very nice, have it, okay, or taste it, okay? So that's what our this pop method does, okay? So whenever you will call, like this is your list motorcycles dot pop, okay, here in this case, it will remove the last item, the item which is present at the very end of the list. Okay, it will remove that from the list, but it will like store that removed item which you have removed. Okay, in a variable. Okay, so here if you see what will happen if we call like motorcycles dot pop, okay, what will happen, okay, this Yamaha variable, okay, will get removed from this motorcycles list, and this Yamaha, okay, will get stored in this popped bike variable. So that's what they are mentioning over here, okay. Like in the list you will be left with only Honda, okay, and this Yamaha will be stored in this popped bike variable, okay. So l- so that's the usage of pop, okay. If you want to like reuse the removed item later, okay, you will use pop, okay. So now let's move on to the next slide, okay. So next slide has like organizing the trapezoid like bookshelf, okay. So what does it mean? The reality of data. So data rarely arrives in perfect chronological or alphabetical orders. User inputs are unpredictable, as you know. So what is your programmer goal? Programmer goal is we need distinct predictable tools to control this chaos. The upmapping operations map perfectly managing this physical shelf, okay. So what is the end goal in simple terms? Okay, you want to turn all this chaos into a proper organized system, okay, so that it's easy to work on it, okay. So you have now certain methods for it, okay, to organize it, okay. First one is this dot sort method. This will permanently sort your list. This will permanently sort your list. Second is sorted method, okay. This will temporarily sort your list, okay. Like what does it mean? Like the actual list, in the actual list sorting will not happen. It will just create a copy of that list, and within that copy, okay, just for the moment you have called sorted, okay, just for that very moment you will like see that list is sorted, okay. So we will see it, okay, in the coming slides, okay. Dot reverse is flipping the shelf backward. What does it mean? Like you will just simply like rearrange the items from right to left, okay, and length is for measuring the total number of items within a list. So now let's see each of these, okay. So here if you see we have physical arrangement via dot sort. So here they have mentioned the dot sort method permanently alters the list order defaulting to alphabetical, okay. So what does it mean? Like it permanently changes the order of the list and it follows alphabetical order, okay. So what is the consequence? Once executed, the original entry order is destroyed. You cannot simply press undo. So what does it mean? Once you have called this dot sort method, okay, the original order in which the list was there, okay, now it's destroyed and now the list is permanently sorted in alphabetical order and you can't undo it, okay. So there is one caveat over here. Python strictly sorts all uppercase letters before all lowercase letters. So that what does that mean? Suppose in your list zebra is there with a capital Z and apple is there. So first Python will sort by uppercase. So zebra will come before apple. Okay. So here if you see, we have this cars list, okay, and here is the item BMW, Audi, Toyota, Subaru. And if we type cars dot sort, so it will permanently change the order of items, okay, within this cars variable, okay. It will sort them alphabetically, so it will permanently do that. So that's why they are saying it's a permanent override, okay. Now let's see the next slide, okay. Next slide is like, suppose you don't want to like change permanently the order of items within a list, okay, you just want to do it like on a temporary basis. So you will use sorted method, you will use sorted method, okay. So how it works, the sorted function generates a temporarily sorted view of the list, leaving the original data entirely untouched in memory, okay. So if you want to understand it, like idle for displaying a clean alphabet list of list to an end user without destroying the raw chronological order of your background data. So what does this mean, okay. Suppose you don't want to like uh, change the order of items within your original list, okay. So what you will do, you will use this sorted method. So sorted, what it will do, it will just create a copy of your list, okay. It will temporarily sort it and it will show you the result, but in the original, okay, in the original list the order is not changed. So if you see over here, okay, we have this bookshelf, okay. This, consider this as your original list, and this checklist is what your sorted function does. So if you see in checklist, okay, you have arranged everything in alphabetical order, okay. But but this order is only for you to see, okay. Nothing, no order of the items, okay, have changed originally in the original bookshelf, okay. In the original bookshelf everything is in the original order, okay. So that's what they have mentioned, never touches or moves a single book. So let's see it through one example. So if you see over here, we have this cars list. Here we have BMW, Audi, Toyota, Subaru. If we type print sorted cars, see it's a function, it's not a method, right? So you can't access with cars dot sorted. You have to like write it sorted, and within this you have to write the variable name. So variable is cars, right? So sorted cars, okay. So what it will do, this will temporarily show you the sorted of that list, okay. But originally in memory, okay, the cars list remains messy in memory. So originally in the memory, okay, the order of items within the cars list doesn't change, okay. So that's what the sorted method does. So now let's move on to the next slide, okay. So next is reverse. So flipping the list upside down, okay. The concept, what is reverse? The reverse method permanently flips the list based entirely on its current order. So it just like permanently flip your list, okay. So if in your list you see you have this BMW, Audi, Toyota, Subaru, when you will call reverse, okay, cars dot reverse, okay, it's a method. So that's why you have to access it with the dot, okay. So what will happen, Subaru will come at the first position because it was at the last, okay. So that's why it will come at the first. Toyota will come at the, it was at second last, it will come at the second position. This was at the second position, it will move on to the second last, okay. And this BMW was at the first position, so that's why it will come at the last position. So it flips from right to left, the order. And there is a crucial like takeaway you have to like keep in mind. dot reverse does not sort the list backward alphabetically. It operates purely on mechanics. The item on the far right is pushed to the far left and vice versa. What does it mean? It's a conceptual trap, okay, to assume like dot reverse actually does sorts the item in reverse order. No, it doesn't do that. It only like change flip the position of the items, like whatever is in the last will come at the first, whatever is in the second last will come at the second position, whatever is in the third last will come at the third position. Okay, it doesn't sort your items in descending order. Okay, it doesn't do that. Okay, so now we come down to the last piece, okay, which is measuring the size of the list. Okay, so the len list function calculates the total number of items inside your list. But unlike list indexing, len counts exactly like a human being. What does it mean? Like index starts at 0. Okay. Index start at 0. But len, okay, len always starts at like 1. Okay. So here this will be one item. This will be second. This will be third. This will be fourth. Okay. So if you count you have this list, right, and you count the highest available index, it will be 3 because index start at 0. But if you count the len, which is like the number of items within the list, it will be 1, 2, 3, and 4. It will be 4. Okay, because length starts counting at 1 but indexes start at 0, the highest index of any list is always length minus 1. So if you see, highest index is what, 3 over here, which is what, 4 minus 1. Okay, so always your highest index will be len of the list minus 1, length of the list minus 1. So now let's move on to this one, length and sorting in memory. Okay, we will see this example. Okay, so first we have this cars list. Okay, we have four items over here: BMW, Audi, Toyota, and Subaru. So first, what we did, total cars is equal to len of cars. Okay, len is again a function, it's not a method, so you won't access it with the dot. Okay, you have to like use len in bracket pass the name of the list. Okay, so when you will call this, what will happen, python counts the number of items within the car variable. Okay, so it will count, okay, 1 2 3 4, there are four of them. Okay, so your total cars, okay, will have like a length of total cars will become 4. Okay, in original memory, okay, cars doesn't change, this cars list doesn't change. Okay, it will remain as it is. Okay, now if you type and now let's see sorted. Okay, so if you type print sorted cars, okay, it will show you a temporary like sorted output like Audi, BMW, Subaru, Toyota. So this is just what you will see a sorted output in your console, but in the memory, cars remains affected unaffected in memory. What does it mean? In the memory, the original position of the items of the list doesn't change. Okay, now what at the last what you did cars dot sort. Okay, you call this sort method. This will permanently like arrange the items within your car list in alphabetical order. So this the physical, that's what they have mentioned, the physical memory is erased and rewritten. Cars permanently become, this time it will be permanently sorted. Okay, so now cars will become Audi, BMW, Subaru, Toyota, means the order of items now is changed. Okay, so in the memory, that's what, if you see, originally we were having this one, right, and now we are having sorted one. Okay, the order has like permanently changed. Okay, now we move on to this one, the literal robot and the index error. So a lot of times, okay, when you run Python code, you will come across this error, list index out of range. So what is this error? So this is the single most common error encountered by new programmers. When this crashes, your program Python, your program isn't broken and it isn't angry with you. It is simply acting like a literal rule bound robot. So what does it mean? In simple terms, you ask for an index, which they are calling a spatial location, that does not exist in memory. The machine cannot guess your intent, it can only crash. Okay, so what does it mean? Okay, like suppose in the list, okay, like you are having a list, okay, in which you are having this A, you are having this B, here you are having C. Okay, and now if you like type, okay, give me A of 3. So if you know, like here you have three items, so what is the index of first item? 0. What is the index of second item? 1. What is the index of third? 2. So max index is 2. Max index is 2, right? But you told it give me like third index, okay, like an index that is 3, but index 3 is not there, so that's why you will get this error, list index out of range. Okay, so you have to like keep in mind the max index if you want to like avoid this error. Okay, so that's what they have mentioning, okay, over here. So what human thinks, okay, I possess a list of exactly 3 motorcycle. I wish to access the third motorcycle. So you have 3 motorcycles. You want to access the third motorcycle. So you like you wrote motorcycles, which is the list, and I want to access the third one. You will write 3. Okay. So what will happen, humans start, okay, because you are human, you will start counting at 1, so you naturally map third item to index 3. Okay, but but in Python, index starts at 0, so item 1 will get index of 0, item 2 will get index of 1, item 3 will get index of 2, and you mentioned index which is 3, right? So in 3 there was nothing, so you will get an empty, there is nothing, it's an empty, so that's why you will get index error. Okay, so in order to fix it, what you have to keep in mind, to retrieve the nth index in any zero index list, you must always ask Python for index n minus 1. So what does it mean? Suppose you want a third motorcycle. Okay, so you have to type the index which is 1 less than this, so 3 minus 1 is 2, so you should type motorcycles and in bracket you mention 2. Okay, then only you will get the third item, because Python always starts count indexing from 0. Next is the empty list trap. Okay, so what is this? The minus 1 index, okay, is the ultimate save shortcut for grabbing the final item in an array without needing to calculate its exact length. What does it mean? Like a lot of times, okay, in order to like get the last item of the list, you will use list, you will use this list and then minus 1, okay, to get the last item. Okay, but here is a catch in which you have to keep in mind. Okay, if your list is empty, okay, where here in this case you can see motorcycles is an empty list, and if you now try to access print motorcycles minus 1, means trying to access last item of an empty list. Okay, so it will throw you an error like list index out of range, because nothing exists in the list, so how you can get the last item. Okay, so always, like whenever you are trying to access the last item, always make sure there is at least like a single item within the list. Okay, and why this occur? Okay, if a list contains 0 items, there is no last item, right? Reaching backward from a void still results in grabbing an illusion. You must ensure data exists before attempting to access it. So now let's move on to the next slide. So now they are giving us three strategies for resilient code. So be detective, don't blindly rewrite crashing code, print the true length of your list immediately. Okay, and why? So often your list is completely empty or much shorter than the assumed because the previous block of code failed to append data properly. Okay, what does this mean? Okay, like whenever you encounter any error, okay, use this print statements, okay, to first like check the length of your list. This will tell you whether your list in an empty string or how many items are there, okay, and it will help you to find that error. Okay, and whenever you want to access the nth item, make sure in the list, okay, the index you are passing is n minus 1. Suppose you are accessing third item, you want to access third item, so in the list pass 3 minus 1 2. Okay, so that will fix that error. Okay, and then if you only require the final item, bypass length calculation entirely by using list of minus 1. Okay, and what does this mean? If you want only the last item, you can use list of minus 1, but make sure first you check like your list should not be empty. Okay, so now where lists are used? So lists are used in every major software application. Okay, to manage and scale, to manage scale and state dynamically. So in video games also we use lists. So how they are used? The game Alien maintains an active list of enemies. So here you see these are enemies. Okay, and when you point a laser and destroy one alien, what happens? The engine, okay, the code, okay, runs this code aliens, which is this collection, okay, dot remove hit alien. So whatever alien got hit, okay, remove. Why we have used remove? Because it will remove the first item. Okay, so like if you see here we have same type of aliens also, but we want to remove only the one which is hit. So that's why the first occurrence should get removed. Okay, so that's why we will use remove method. Okay, in Spotify, okay, a playlist is nothing more than a Python list of specific song IDs. The sequential order of the list strictly dictates what plays next. Okay, so in Spotify, you know, you set your songs in a specific order, like in this order, my list of songs should play. Okay, so that is again a list. Okay, in data analytics also, okay, what happens? Okay, in the morning, like suppose you have an empty list temperature, okay, and you keep on appending like temperature value every, let's suppose every 10 minutes. Okay, so in the at the end of 24 hours you will have a list of temperatures. Okay, and this can be used to build automatically massive data sets. Okay, so now we have like looking ahead scaling to 3 million. Up to this point, we have interacted with list items one by one. But the true superpower of lists is that they allow software to handle millions of data points using the exact same code that handles three. What does it mean? Like the same in if you have a list, okay, and it has like just some items like three or five, and if your code is working for that five items, you can scale it to like 1,000 items, 10,000 items. Okay, so that's what they are meaning. So users over here is like these many email addresses are there, this it's like 1 million. Okay, and you call a loop over here. So for each of these email address, okay, you are sending the mail. Okay, so what you are essentially doing, you are like looping through this users list. You are taking one item at a time, okay, based on its index. Okay, and then you are sending. that item which is the user, in this case a male. Okay, so that's what you are doing. Okay, so next they are mentioned, in the next phase we will introduce loops, the mechanical capability to look at an unimaginable massive list and process every item automatically in just 3 lines of code. Okay, so this is what we have covered today. Okay, like in the list, this is like kind of an appendix of what we have covered. Okay, uh, and after that, okay, this is the overall summary. Okay, and the key points what is covered in this chapter. So now we come to the end of it. So thank you.